Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at building up strings within your application. I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. What we're going to do today is we're going to take a small simple CSV file shown on screen here, which has a number of records in it, and we're going to use this data to demonstrate the addition of strings. So if we have a look at the template code I've prepared so far, what this is doing is quite simply specifying in the str file name the name of the file to load. We're then using one of our prepared library functions to load that file into an array, and then for each record in the array we're pushing the record out to our log. So if we run our program now, we'll see it quite happily puts each of the data lines out to the screen. Now what we're going to use this to do is we're going to use this to demonstrate the accumulation of data in a string. In the applications that you write, you may well be taking data and adding it onto a string to build up a report during the time of your program's running. This can be a very easy way to assemble an output in one string variable. So we're going to add some variables up here at the top of our code, and we're going to be using these to read through this array. So what we'll do first of all, we will make sure our output string is empty. And this is the string variable we're going to be accumulating data into. So the first thing we want to do is to work out how many columns are in this data. And we will use the parse count command on the first element to work out how many columns there are. So we're using parse count on the 0 element of this array, and we're counting how many elements using the comma as a delimiter. And this should tell us how many columns we need to read through. And then we're going to use a simple for next loop. So we'll place this bit of code up before our existing for next loop. And we'll take out that, and we'll put a nested loop inside our first one. Now for each column we want to pull the data out of it. So we're going to use a temporary variable and the parse command to pull out the element of the array we're actually looking at. So this would contain the whole line, which has embedded commas. We'll give it a delimiter of 2 double quotes, which will allow us to handle any embedded commas. The parse command is very good for that. And we'll use long C to say which element we're after. And then quite simply, we'll then append to our output string. And I'm going to add on to that a double quote character, the value stored in strtemp, another double quote character, and a comma. So by the time we get to the end there, we will have in str output the entire line, effectively wrapping everything in double quotes. Now since the last character in the line will be a comma, we're going to trim it of the last comma, and we'll add a control line feed on to the end. Now at the end of all of that, we can quite happily push our value in the str output variable out to our log. So if we try running this now, we will see that the data is quite happily going out, being read in, the string has been accumulated, everything's been wrapped in double quotes, and it's been pushed out to our log. That works fine. But one thing you may want to do in much of your code is to work out how long does it actually take to perform the functions you've asked the code to do. So one thing we can do to work out how efficient our code is to use the ticks command. and we'll give it a quad variable we set up already, and this will count our clock cycles. And down at the end of our code we will put a takes n command in, and after we put the data out on the screen we will put another log command out which will have in it the number of cycles. So if we run that now, we'll see that we used 200,000 cycles. So that gives us a baseline. Now what I'm going to do now is I'm going to change one line of code. Where we're building up the value in str output, we're going to use the build $ command. And the build $ command takes a list of variables and it basically adds these all together and puts the value into your str output. The beauty of this particular function is it has an almost unlimited number of parameters it can accept. So it's doing exactly the same as the previous line. It's taking str output, the double quote, str temp, another double quote and a comma, and adding them all together and placing them into this variable here. So if we comment on this first one and run our code again, the number of clock cycles used has actually dropped dramatically from 200,000 to a mere 140,000. That's significant. So just in case there was some kind of caching going on in the background, let's run the original code again. 197,000, close to the 200,000. And if we run our amended code, 132,000. So just by changing a single line of code, you can dramatically increase the speed. However, to achieve this level of efficiency, there are some compromises made in the build $ command. You can't use functions as one of the parameters. They have to be string literals, constants, or array strings. However, in certain circumstances, like we have here, it's a very efficient way of actually building up a string. Now, perhaps there is a faster way of doing it, or certainly an alternative way. And what we can do, we can try this one out, again using our tix command. We're going to create a new variable here. We're going to be using a class which is inbuilt to PowerBasic called iStringBuilderA. Now, StringBuilderA handles ASCII strings. StringBuilderW will handle wide or Unicode strings. Now, as we're just using plain ASCII here, we'll just use the StringBuilderA. So having set that up, we will do what we did before. We will use our tix command, which will start our timer. And the first thing we did before was we cleaned out the variable. Now, as we've just created it, it will be empty anyway, but let's just do a clear on it. Now, the string builder command will attempt to work out how big this string is going to be for you, but you can actually improve efficiency by giving it a guess of how big it's likely to be. So let's say 5,000 characters. And again, we'll have to count how many columns there are, just as we did up here. So we'll take exactly the same line of code and push this one in. And we're going to take the same approach in a for next loop. So no different to what we've done already, as we're doing a for next loop for each of the columns. What we do next is use the add method. We're basically going to add on to SP output the information we're after. So we're adding on a double quote. Now, to save a bit of typing, I'm going to use the prefix command here. Makes our code that wee bit more readable. So we're first of all adding on the double quote. We're then adding on what we had up here. and then we're adding another double quote, and then finally a comma. So once we get to the end of the columns, we'll want to basically take off the last comma. Now how we do this in this particular class is using the delete method. Now we'll need to tell it two parameters here. One being the number of characters we wish to delete, which is 1, and the first parameter is at what position we wish to start at. Now we can quite happily get that using the length method, which tells us how many characters are in the string so far. And then to finish off, we'll use the add again to add on a carriage return line feed. Now once that's been done, we'll want to output the string we've built up out to our log. And if we put in sboutput.string, this will fire it out to our log. Now we'll want to close off our ticks command at this point, and just as we did before, we will fire out the number of clock cycles just to see how fast this is going to be. So if we run this now, there we have our clock cycles for the first method, 132,000, and using the new method we get exactly the same data going out on screen, but we've now managed to get the clock cycles down to a mere 94,000 clock cycles. Again, a considerable increase on what it was originally. So for comparison, if we put our code back the way it was coded originally, and run again, as you can see we've gone down from just under 200,000 clock cycles down to 93. So you can quite happily say we're now processing twice as fast, with only a marginal change to the code. Now, while this is a very small amount of data to actually handle, and the difference between 93,000 clock cycles and 194,000 clock cycles is fairly minimal, if we were perhaps processing 1,000,000 records or more, then that could add up to a considerable length of time. So much of the time in your code when you are actually adding strings to each other to accumulate a string you're going to use at the end of the code, there are alternatives just to adding to the dynamic string. That's it for today. Thank you for watching.